My name is Charlie Moreton. I am one of the ICE technical marketing engineers. We have Pavan Gupta as part of our Q&A panel, which is great because he is our certificate expert. So I'm sure he's appreciating me calling him out for that. So you'll see that we have both the beginner and the advanced diamonds on this title screen. And the reason for that is, although we're going to be automating the renewal of our public certificates with Let's Encrypt, I want to give a quick breakdown as to what exactly certificates are, why we use them, and how we're going to use them in ICE. So in order to accomplish that, we're going to go through some terms that are going to be needed so that we can understand the different roles and functions of everything as far as the hierarchy of the certificate chain goes. We're going to go through and actually talk about what a certificate is, how it was first implemented, created, and why we still use them today. And then we'll get into the juicy stuff with the Let's Encrypt and how we can use it in ICE. So here's a list of terms. I'm not going to go through and talk about these terms. I'm going to keep this up on the screen for anybody who's got, screenshots, or for anyone watching this on demand, you can pause the video and take a look at these terms and the definitions, because we're going to talk about all these terms. Hopefully by the end of the webinar today, you'll know what everything in here means, and you're not going to have to refer back to this a lot. Basically, a digital certificate just tells other electronic devices who you are, what you are, and it gives an identity. Really, that's basically what it is. And we all know that with an identification card, we have some sort of an authority telling others what we are. So for us, we like to say, hey, it's a driver's license, right? So we have these driver's licenses that have all this information about us as an individual. And I'm showing on the little box, that's the back of the driver's license, where you have that little funky barcode in there that nobody can read. So the way that we kind of describe this in certificate world is that you have all the same type of information, different names, and in different places. But if you take that jumbled up barcode, that's going to be what we have as our public key. And that's kind of an encrypted base 64 value. And then the extensions, that's going to be how we're allowed to use the certificate. You know how you have the exclusions on the back of your driver's license that say you have to have your reading glasses, you can only operate a regular on-road vehicle, you don't have a commercial license. Well, your extensions is kind of the same way for a digital certificate. And we'll get into that, and you'll see how that's used as well. Now, this is the text file of a digital certificate. So if you're going to look at a certificate either in your terminal window or in a text editor, this is what you're going to see. It's small text right now. We're going to blow it up. We're going to talk about it in a bit. So you don't have to worry about going through it right now visually. I just want to talk about more about the hierarchy of these certificates. So if we take a look, this is our identification that we were shown earlier. So that's us as a subscriber. Now the subscriber is the entity that is requesting a certificate, whether it's a user or a device. All right. So we're going to request that certificate, and that certificate request is going to go to a root certificate authority. Now, if we keep the analogy of the driver's license or the identification that is issued by a government entity, then your root certificate authority is like the federal government, the government of the country in which you reside. In our case, it would be a passport, right? That allows you to travel to other countries uninhibited, and you can share that identity that's been vetted federally at the highest level so that you can do that. Now, we also have the intermediate certificates. And if you think about that as the government issued IDs, that's going to be your state or locality issued driver's license or other identification. So that allows us to travel around in that country unencumbered, but we can't take that and travel around to other countries without having that passport. Then ultimately that gives us our little card that we carry in our wallet as our driver's license. So if you think about your digital certificates the same way you do a driver's license, this is kind of how they're going to be issued in the hierarchy that's involved in them. the certificates that we use for websites, for authentication, all of that are X.509 certificates, and specifically they're the version 3 of those certificates. And to understand how they're used, we need to understand the data structure and some of the encryption formats that are being used for these certificates and how they're used in the communication between me and a server, or my laptop and a server for authentication. So there's a lot of text throughout this whole webinar because there's a lot of information to give. Certificates can be very complicated. I'm going to try to simplify everything for you. The first point, though, is very important. Certificates were first standardized in 1988. Okay. That's almost 40 years ago, 3 years away from 40 years ago. So it's a very old technology that we've been using. And it was first used and made as an effort by telecommunications companies. If you see that third point, it was supposed to be a global telephone book. This is supposed to be take care of the, the yellow pages, the white pages that we used to have. Half of you guys don't even know what I'm talking about, right? Because they used to print out directories of everybody's name, address, and phone number in these large books and put them out there. Well, they were trying to do that digitally so that we could have an electronic record of that so that everybody could know who everybody was. It never happened. It was not something that should have happened. I'm glad it didn't happen. I don't need all that information about me easily findable. So if you've ever looked at the certificate and you wondered why we have different places for, state, locality, country, or all the different location-based information, well, the reason is because it wasn't designed for anything except a phone book. So those little parts of it still remain. Matter of fact, if you take a look at the distinguished name of a certificate, you can see where we have these different locality informations embedded into the subject name of our certificate. Now, I also added the X500 attribute type here. These are the attributes that you would use if you're using like APIs to call for a certificate or to import a certificate into different servers if you're doing raw certificate importations. Now, X509 builds on the ASN.1. We talked about the ASN.1 in the little certificate agenda, and that's the abstract syntax notation. That's what we're using to be able to define what we're defining. If you see underneath the attribute types, we have the object IDs for all these attributes. And object ID 2.5 is directory services, right? So we're in the directory services ASN to provide a certificate. Again, it harkens back to the phone book that we were trying to build. Now, let's go back to our certificate and all the text that I had on the side. We're going to blow this up a little bit. And this way you can see where all the information is as part of the certificate. We've got our serial number, who issued it, right? We want to know who gave us the certificate. And if you see here, it was issued by Let's Encrypt, and their signing authority was E5. We'll talk about that later. That's an intermediate certificate authority. The validity is, every certificate has a born on date and an expiration date, and that's just where your validity comes in. Our public key, that was the part that was the base 64 encrypted on our little driver's license card. Then our X509 v3 extensions. If you remember those are going to tell you what we can and cannot use the certificate for. Now, we talked about the city, state, and organization, the locality-based attributes for these certificates. They're optional. Matter of fact, best practices now state that we don't even use them. We don't need them. We don't need them taking up space or different bytes within the certificate file size. They're not relied upon for anything that we're doing, so we just don't use them. And if we go back and look at these extensions, you can see there's a lot of lines here. The most important one is the extended key usage. What are we actually using this for? And this is a web certificate. You can see this is for a web server on the internet. Web server authentication and web client authentication is what this is used for. It also says that this is not a certificate authority certificate. This is just for a web server. It's not going to be signing certificates. It won't be issuing certificates to other entities. Then down below that, you see a subject alternative name. Instead of using the distinguished names, we're using the subject alternative name more and more, because as you can see, we can have more than one name in the subject alternative name. We can have one certificate and apply that one certificate to multiple servers just using the DNS names that are listed in the subject alternative name. The only requirement for the subject alternative name, the SAN as we call it, is that you have to have at least one for every certificate. You can have as many as you want. There is no actual limit, but you have to have at least one. Then if we come down here, you can see that we have the signature value. This is what has been given and assigned to the certificate from our certificate authority as it's been signed as a valid certificate. And that tells you that, you know, the website that you're going to be visit is secure because it has a valid signature from a well-trusted certificate authority. Whew. I know that's a lot, but we're going to even more. Here's some more information for you. So there are encoding rules for these certificates. Now the raw certificate, that's the distinguished encoding rule for your raw certificate. That's what the DER stands for, the DER for the raw. That's all binary. So that's ones, zeros. We all know binary when we see it. We can't all read it, especially when it's a lot of it in a format such as this. So we take that and we wrap that into a privacy enhancement. What that is, it takes that binary format and encodes it in base 64, and it gives you your header and your footer for begin and end certificate. All right. So that's your certificate right there, just that base 64 encoded. And to secure your certificate, you have a public key. Now the public key, it follows the public key cryptography standard, so PKCS. And we'll talk about PKCS more in a minute. And that's also base 64 encoded with a header and a footer. So you take both of those, your privacy enhanced mail, your PEM, and your PKCS file, and that's how you get a secure certificate. Now, let's talk about PKCS a little bit more. Now, we talked about public keys, we talked about private keys, although it was quickly. We're going to talk about them a little bit more. Now, the RSA labs actually came up with it. That's why you see that little RSA logo on the top. They came up with the algorithm that defines what a public and private key are and how they interact with each other. With this, we've got 3 different PKCS formats that we rely upon for server-based certificates. If you've ever started a web server and you had to upload your PKCS or your PKI or your server certificate to it, it's going to ask you for a specific format in which you need to upload that certificate. Now, PKCS 7, that's got your certificate chain that we talked about, your root CA, any intermediate CAs, and the CA, the subject CA that the server itself has been issued. And that's all packaged up, and you can put that into a single file, and you can upload that to your server. Some servers want your private key separately, so that's PKCS number 8. So a private key is encrypted or encoded and sent as a separate file to those servers. And the logical evolution of that is if you take the certificate chain and you bundle that with your private key, that's PKCS number 12, then that can be all put into the same file and uploaded to the server as well. Now, web servers don't have a standard on which one of these PKCS formats you use. Some of them require one thing, some of them require another. So it's up to the actual web server to tell you what they require so that you know what to upload to that server. Public key infrastructure is another thing for certificate issuance if you're not using like a web host, if you're not using a web server and you want to do authentication certificates, whether it's user, device, 802.1x, TEAP, any of that. Public key infrastructure is something that you have on your network that will issue certificates to users and devices on your network so they can authenticate to that network. I know there's a lot of round robin there, but that's what it is. You own it. You control the validity dates, how long the certificate is valid for, whether it's 1 month, 3 months, 1 year, 3 years, 5 years. That's up to you as that PKI holder. You can configure anything that there is that you want to for it. You can actually create your own certificate templates so that you have a uniform and consistent certificate on your network. We're going to talk about both of these, the web PKI and your private PKI right here. So web PKI, like I said, that's HTTPS, that's your web servers. It's covered in RFC 5280. Now, everybody knows that if you don't have your server certificate, then you get the familiar, hey, your connection is not private and you have to do a little bit of a workaround to get to the actual server, but you know that it's not secure. It's the HTTPS that you see here that tells you that it's a secure server, right? So if you can get to it through HTTP and it doesn't automatically redirect you to the HTTPS, that's the first step that it's not secure. And then if you get this error, you know it's not secure. Their certificate might have expired. They just didn't bother to upload a certificate. And then your internal PKI is going to be something that you have on your network, and it's typically going to be assigned to anything that's on your network as far as your RFC 1918 addresses. Any of the private addresses that you use on your network would be able to get these. So you have an internal intranet. You can assign a server certificate for your intranet, for your ISE admin portal, because you don't want to expose your ISE admin portal to the internet. You assign that certificate from your internal PKI, your CA server, so that you don't get the certificate warning when you're logging into it from an internal machine. Now, the thing about the web PKI and the public certificates is that they are actually prohibited from use on private addresses. You can't use a web PKI certificate on one of your 1918 addresses. And that's just to keep everything separate. And it lets you know that this is a publicly valid certificate if you're using a web PKI, whereas the other one's been had its validity checked by your internal certificate authority, which means it's only valid within that network. It's not valid on any other network. So that's the difference here. Then you see I have public PKI in here, and I put that on here because I know questions are going to come about the public PKI. It's just web PKI. Sure, you can do a public PKI, but for the most part, it's web PKI, and that's what we're using. And it's just to assign certificates to web servers. You don't really want a global PKI that can log into anything using authentication methods. Well, that's great. But how do I trust these root certificates so I don't get these certificate errors when I'm trying to go to a website? Well, most of your root CAs, the top tier CAs, are already in your trusted store, whether it's in your operating system, Windows, Mac, Linux, they all have a trusted certificate store that have the top level root certificate authorities in them. Same with your Android or iOS phones, even web browsers, your Mozilla Firefox, your Chrome actually uses the certificate store that's on your machine. So all of these entities already have the root CAs installed on them so that they already trust that level of a certificate authority. So how do I get to be trusted? Well, that's where we're talking about a certificate signing request, which means I want a certificate authority to sign my request, whether it's a public CA or my internal PKI. I want them to say, yes, I've checked the validity of this identity and it is correct, and it is now a secure communications. So the CSR contains a public key that's automatically created by the entity that's creating the request, the name and the signature. You send that to the certificate authority, and it says, all right, now I have to validate this. And how does that happen? Well, that happens because it does some external validation to ensure that you are who you say you are. I can go and I can say, hi, I'm Charlie all day long. But then I can go and talk to Rigo, he's our host, and he hasn't met me before, right? So I can say, no, I'm Mike. You have to trust that I'm Mike because I just told you I'm Mike. Well, how does he know that? And it's obviously not true. So external validation, he would ask our Q&A panelist, Pavan, hey, is that really Mike? Say, no, that's Charlie. Don't trust him whatsoever. He's a crazy guy. So we need to do the same thing with certificates. And there are 3 ways of doing it. The domain validation is one way of doing that. And we'll talk about that a little bit because that's what Let's Encrypt uses. It's also one of the easier validations, which makes it the most widely used, right? Organization validation is, hey, this is the name of my business. This is where I am. Please trust who I am. And sure, that can be a validation point. It's not consistent. You can send different types of information. It doesn't have to be the same. It doesn't have to be formatted the same way. So although it's used, it's not used as much as the domain validation because it's not as true and actual proof that you are who you say that you are. Now, the extended validation is like the organizational validation, but it goes deep into it. So those who need very secure certificates will follow this route. They're going to do a public record search. They're going to do attestations, which means they're going to send someone a piece of paper that says you have to attest to the fact that this company owns this and you are this. And you have to actually sign that with an ink pen and send it back for them to get that. So it's a written legal record at that point. And that can take a few days or even weeks to get back. So a lot of times that's just not used unless you have a very secure certificate that you need to get for one of your servers. The other thing, we've said it already, but certificates do expire, right? And they should. Every certificate has that validity date that we talk about. So you have a not before date, that's your issued date, and a not after date. So that's the date of expiration. And you want to make sure that you do a certificate renewal. You get a new certificate to replace this one before its expiration date. So you don't get that not a trusted server or cannot access the server error in your browser. And the way that we're going to be talking about that is through the use of ACME. Now, ACME is the technology that Let's Encrypt uses. There's a draft IETF RFC out there that Let's Encrypt co-wrote. Cisco is also one of the co-writers, but as Cisco does, we're a little bit slow in implementing it in all of our technologies and products. So we can use automation with ACME to automatically renew our certificates. Again, it says we don't use email verification anymore. We use the domain verification. What that means is ACME will tell us when we go and register for the certificate, it's going to say, you need to place this TXT record on your domain server, so on your DNS server, so that I can read that and see if that TXT record does exist. I know that you did that because it has to be manually entered. Then I know that you are a valid entity and I can issue the certificate. The reason that this is important is because April 14th, just over a month ago, it was announced that your certificate lifetime dates are being severely reduced. We have 1 year until we're reduced to 200 days, right? Less than a year, actually. What that means is you no longer have a 1 year certificate. You know, people are enjoying their 3 and 5 year certificates, but they're going to be reduced to less than a year now. It's just over 6 months. It's about 7 months here. Then a year after that, we're going to reduce it even more to 100 days. So just over 3 months before you need to renew your certificates. But by 2029, 47 days. Okay. That's a big deal. That's a month and a half. That's a lot of administrative overhead. It's a lot of time that you could be doing something far more important than just renewing certificates all the time. Because how many people only have one server that needs certificates? You got throughout your whole infrastructure, throughout your whole network, you have all these servers. They're going to have their certificates renewed. So being able to modify and automate this process is going to greatly help everything that you do as far as certificate renewal goes. And that's why we're using Let's Encrypt. It's free. You get public certificates for free. It's automated, open source. Heck, it's a nonprofit agency. They take donations to be able to keep going. So yeah, that's a pretty big deal. ISRG root, that's the root certificate authority. If you look in your trusted store on the computer that you're on now, you have this root CA already installed in your computer. So you already trust it. So you don't have to worry about going to any Let's Encrypt certified sites and getting the certificate error. Let's Encrypt certificates are only valid for 90 days. So by using Let's Encrypt certificates, you've already reached the milestone of 2027 of 100 days or less, right? So use the Let's Encrypt certificates and you have to revalidate every 90 days. Although you can change that, you can do it for lesser times as well. So just changing your scripts or your cron jobs to 45 days would put you in line with the 2029 referendum. You can also use wildcard certificates using ACME. ACME V2 uses it, which a lot of times that's the default when you're using different utilities to be able to get your certificates from Let's Encrypt. So how do I use this in ISE? Well, short answer is you don't. All right, let me explain what I mean. This is an issue of semantics. You don't use it in ISE. We do not have this technology built into ISE at this point. It's something that we're looking at and maybe in the future, but it's not in 3.4, it's not in 3.5, okay? I'll just get that out of the way right now. How do you use it with ISE? Well, that's easy. We use certbot to go and we grab the certificates from Let's Encrypt. You tell certbot that you want to get certificates. It says, how do you want to do your validation? I want domain validation. Who are you? Here's what I need you to put on your server. And then says, all right, I've issued you your certificate. And it puts that certificate into a specific place on your computer. From there, you use Ansible to run a playbook to use the APIs within ISE to be able to push that certificate to ISE. Sounds like a couple manual processes here, but it's only manual the first time that you do it. Just like anything that's automated, you first have to set it up before you can take advantage of the automation part of it. With the automated renewals within the certbot or within the Ansible, you just set up a cron job, right? Crontab is the command that you would use. And if you use crontab-e, it's going to open up the configuration file. Now, the format for the configuration file is shown here, the minute, the hour, the day of month, month of day. So you put everything within that format. As you see, the entries that I put in here is the minute is 30. So 30 minutes after the hour of 00. So 12:30 in the morning on the first day of every month, because the stars mean every. So every month, every day of the week, it doesn't matter which month or what day of the week, the first day of every month at 12:30 in the morning, I'm going to run the renewal process. And then half an hour after that at 1 o'clock in the morning, I'm going to run the playbook that says, take the certificate that I just renewed and upload that to ISE. Okay. So let's go ahead and do a demo on this. I am foolish enough to do a live demo. All right. So here we are. This is my ISE primary policy admin node. Now I'm getting my certificate error. And if I click advanced and then tell it to proceed, then it will say, all right, you're safe. I don't want to do that here because I want to show that my sponsor portal, I'm going to refresh that real quick. It was a fast refresh. And then my guest portal as well, right? So if we go here, you can see I'm getting these same errors on both my sponsor and my guest portals because I don't have anything but the self-signed certs on these portals. Now I'm going to first get out of here. All right. The first thing that we have to do is install the certificate authorities that are part of the certificate chain for the Let's Encrypt software. All right. So we're going to import the Let's Encrypt root certificates on the ISE primary policy admin node. I'll show you the playbook when we're done here because there's a stupid way that you have to import these certificates into ISE. It's detailed in the Open API documentation, and I'll show you exactly what that means and how to use that within a playbook as well. So now that the certificate authorities are there, we're going to install the certificates. So let's get rid of the root here, just do the certificates. In this case, it's just a single certificate. And now we have that certificate installed into ISE. So if we go back over here and just refresh the page, I'll refresh my guest portal as well. Well, anyone who's ever done this knows that live demos is where it's at, right? There we go. It's still not doing it. All right, so I'm popping back in here to let you know that the failure that we just experienced at the end of this webinar was due to Chrome's enforcement of the high HTTPS strict transport security protocol, which basically means that if a certificate has changed on host too often and Chrome cannot verify the authenticity of that certificate to the host because of that, then it'll give you the error that we saw during the webinar. So yeah, I'm saying it's a Chrome issue, but just between us, it was a Charlie issue. My head just wasn't working properly at the time. So as soon as the webinar finished, I opened up Firefox, went to my ISE admin node, and everything just worked properly. It established a secure connection to the HTTPS port on ISE admin node. I was able to log in correctly, and everything just worked. So the great thing is that right before I signed on to give this webinar, I tested this out and it all worked great. But let's go ahead and take a look inside ISE real quick so that we can see that the certificates have been updated. Oh. All right, so if we take a look at our system certificate, you can see that our portals certificate is here, and it was issued by E5. And the certificate expires within 90 days because, like I said, Let's Encrypt only has 90-day certificates. It's issued by E5 because if we look at our trusted certificates over here, let me make it so you can actually read it. We have our Let's Encrypt root certificate, and that was issued by E5 as its root authority. And if we look at E5 here, that was issued by the ISRG root certificate. So that's our hierarchy here. We have Let's Encrypt to E5 to ISRG root. And that's why the certificate that we have for our portals was signed by E5. So we go back over here to our, let's try our guest portal again. it's going to give us the error because it's an IP address, and we don't have the IP address in our subject alternative name. There you go. Now you can see, oh, that it's still not secure. Certificate is valid, issued to, and it's let's encrypt. So you can see that the certificate is on our portal. Let me go in here and delete my browsing data. Kill those off. Make sure I delete everything. Site settings, yep. Well, there we go. We're still showing not secure, but our certificate is there because, hey, live demos, right? Yay. So while this is in its nice state of limbo, let's take a look real quick to see what we have to do to actually get these certificates into the format that we need for ISE. If you see here, what I'm doing is I'm taking these certificates. These are the root certificates that I downloaded, and I'm running this command. And what this does is it strips out any of the new line or spaces in these certificate files, right? So if we take this command and go into our terminal and run that same command, you see that the output is that same certificate that I showed on the slide with, base 64 encoding. It's got the /n character for any of the new lines, but this way it doesn't actually create that new line. And it's got the header and the footer. So this is the format that ISE needs to be able to read a certificate through its API. And now if we take a look at the actual server certificate itself, what I'm doing here is when certbot downloads that certificate, it downloads the certificate to this file. So I'm copying it to a different destination file so that I can keep my original file just the way that it is. So I'll copy it there, and then I'll run that same command on that certificate and on the private key so that I can get the same formats, then upload those to ISE. That way, whenever I get a new certificate that comes in, it just overwrites where I copy it to, and then I can do the same thing. And every time that this runs, it'll overwrite that certificate file, it'll run this command, and it'll upload it to ISE. And then by using that cron job, it'll do it whenever I want it to do it. So I just have that cron job so that it runs, like I said, on the first day of every month. So that'll be a 30 to 31 day recycling or renewal of that certificate file. I wonder. No, I can't tell you why it's doing that, and I'm sorry that it is. But hey, that's what we get for doing a live demo, right? So apologize for that, but we're going to move on. We do have a survey after this webinar. I know that it's not a full 1 hour webinar, but I think we covered all the top information that we wanted to. But I did want to make sure that you guys got these resources as well. These are really good resources that I use to help build what I showed here a couple really good write-ups on our ISE community that you can read as well. And then, of course, plenty of other webinars, resources, community information that you can look at. Iceberg is one that hopefully everybody already knows about. If you don't, go check it out. I think you're going to love that as well. That's where we compile all of the different configurations guides we have for any technology that either touches or integrates with ISE.